Dear students, today we learn the relation between linear velocity and angular velocity and linear acceleration and angular acceleration. So in this circular motion, so let it be the particle moving from A to B. A to B, the arc length is L, the radius is R, and angular displacement is theta. So that means from the circle we know that arc length equal to radius into angle here. So what is the arc length here? L, radius R, into angle is theta. Suppose the particle moving further B, what will be changes? L will change and theta will be changes. So possibilities dl r into d theta. R is radius, remains constant. So now divide with respect to the time. Divide with respect to the time both sides here. So dl by dt, r into d theta by dt here. We know linear velocity dl by dt here, angular velocity omega d theta by dt here. So therefore dl by dt nothing but a v equal to r into d theta by dt nothing but a omega. So that means v bar in vector notation, r into omega bar here. So the relation between the linear velocity and angular velocity, so v equal to r omega. So omega is angular velocity, v is the linear velocity. So again you can derive it with respect to the time above the equations. So let it be take dv by dt is equal to r into d omega by dt here. So divide with respect to the time both sides here. So that means you know that linear acceleration a equal to dv by dt here, and angular acceleration alpha is nothing but a d omega by dt here. So therefore dv by dt nothing but a, so then r into d omega by dt nothing but a alpha. So that means a bar equal to r into alpha bar. So that is the angular acceleration, and linear acceleration are vector physical quantities. So therefore a equal to r alpha. So that means in these two derivations, linear velocity v equal to r omega, one derivation, linear velocity equal to radius into angular velocity, and linear acceleration equal to radius into angular acceleration, these two derivations in circular motion. So they will give radius and angular velocity to find linear velocity. They will give radius into angular acceleration, you can find linear acceleration in the circular motion. If you understand, thank you.